Hey guys, Mr. B here, and in this video we're going to be going over the practice problems for chapter 12.3 on Newton's third law of motion and momentum. So let's start here with number 1. It says, according to Newton's third law of motion, what happens whenever one object exerts a force on a second object? All right, so Newton's third law is all about action-reaction forces. And basically Newton's third law says whenever one object exerts a force on a second object, the second object exerts an equal amount of force back on the first object and in the opposite direction. Okay, so this is exactly what Newton's third law says in the notes, but whenever one object, there we go, it's fine. Whenever one object exerts a force on a second object, the second object exerts an equal amount of force back on the first one, but in the opposite direction. Number 2, the equal and opposite forces described by Newton's third law are called blank and blank forces. So these are called action and reaction forces. It doesn't matter if you want to put reaction and action or action reaction, so don't worry about what blank you put them in, but action reaction forces. Number 3, circle the letters that identify each sentence that is true about action-reaction forces. So Newton's second law describes action-reaction forces. Nope, that is not true. That is Newton's third law, so not that one. Forces always exist in pairs. That is true with action-reaction forces and all forces, so that is true. Action-reaction forces never cancel. That is also true. They don't cancel with each other because they're acting on two different objects. So, and then D, all action-reaction forces produce motion. That is not true. They do produce motion sometimes, but not always. So that's not true either. So B and C are true, and A and D are not. Number 4, true or false? Action-reaction forces do not cancel each other because the action force is always greater than the reaction force. So this is false. It is true that action-reaction forces do not cancel each other, but it's not because the action force is always greater. It's because each force is acting on a different object. Therefore, they don't cancel. If they were both acting on the same object, then they would cancel out because they'd be pointing in opposite directions, same size, same object, then they'd cancel. Number 5, circle the letter of each factor that affects the momentum of a moving object. All right, so momentum is two things, okay, that determine momentum. One is mass, and the other is volume. So of the two factors given here, we have A for mass and volume. Sorry, mass and velocity. I apologize. Mass and velocity. They both start with V's. So mass and velocity. So A and D are the right choices. B and C are not. Again, I apologize. Slip of the tongue there. Number 6, if two identical objects are moving at different velocities, the object that is moving faster will have blank momentum. So since momentum is determined by mass and velocity, if you have two identical objects, that means they have the same mass, but if they're moving at different velocities, the one that's moving faster will have more momentum. So, number 7, your roller skates are sitting in a box on a shelf in the closet. Okay, first off, who has roller skates these days, right? I mean, that's like the 70s. But anyway, they're sitting in a box on the shelf. What is their momentum? So the key thing to know here is that if the object is not moving, it has zero velocity. And if it's not moving, it has zero velocity. It has no momentum. So I'm going to say their momentum is equal, there you go, to 0 kilograms times meters per second. So basically, they don't have any momentum. Okay, if they're not moving, you don't have momentum. Number 8, true or false? An object with a small mass can have a large momentum if the object is traveling at a high speed. This is true. So there again, the two factors that determine momentum are mass and velocity. So if your mass is small, but your velocity is very high, you will have a lot of momentum. Key example of this would be a bullet, right? Bullets are not very big, but they travel at a very fast speed. They're very difficult to stop. They have a lot of momentum. So, yeah. Number 9, circle the letter of the object that has the greatest momentum. Okay, so giving us a bunch of different objects and examples here that are moving at different speeds and different masses. To determine the greatest momentum, we'll need to use the momentum equation, which is momentum, which we have as P. Okay, so P is the symbol for momentum, not M. M is for mass. So P, momentum, is equal to mass times velocity. The units of momentum are typically going to be in kilograms times meters per second. The units for mass will be in kilograms, and the units for velocity will be meters per second. So all we're going to do is we're going to take the mass of each of these objects, multiply by the velocity, and whichever one is the largest is our answer. Okay. Now letter A is in grams, and it should be in kilograms. So to do this math out, we will take, instead of 700 grams, we'll take 0.700 kilograms. Okay, that's 700 grams of kilograms times 2.5 meters per second. And let's see what we get here. So 0.700 times 25. Oh, sorry. 0.700 times 2.5. You get 1.75 kilograms times meters per second. Okay, so there's that one. 1,000 times 5, that would be 5,000 kilograms times meters per second. Letter C, we will take 40 times 0.5, so 40 times 0.5, that's only 20 kilograms times meters per second. And letter D, a 300 kilogram roller coaster traveling at 25 meters per second. So 300 times 25, that gives us 7,500. So it looks like of each of these, letter D is the correct answer as to which one has the most amount of momentum. Letter D. All right, number 10, true or false. Objects within a closed system can exert forces on one another, but other objects and forces cannot leave or enter the system. This is true. So a closed system means that everything inside the system can interact with each other, but things outside the system cannot interact with them inside. So that's true. Number 11, according to the law of conservation of momentum, what happens to the total momentum of a system if no net force acts on the system? So conservation of momentum basically says the total momentum is conserved as long as nothing acts on the system. So we can just say the total momentum is conserved. So it doesn't change. All right, number 12, true or false. In a closed system with two objects, the loss of momentum of one object equals the gain in momentum of the other object. Yeah, this is true. So if you have two objects in a closed system and one hits the other one and it loses momentum, then the second object will gain all the momentum that the first one will lost, because again, the total amount of momentum between both objects has to remain the same. So it just transfers. All right, last question, number 13. It says the momentum of the ball at 1 second is... All right, so we have a graph. It looks like we have momentum on the y-axis and time on the x-axis. And at 1 second right here, we have this point here at 2.5 kilograms times meters per second. So it looks like the momentum of the ball at 1 second is going to be 2.5 kilograms times meters per second. And that is the ball's momentum. So, all right, cool. That's it for this section of notes. And actually, that's it for the chapter. So if you have any questions on any of the concepts, of course, as always, you are free to email me or chat with me in class so that you can get your answers, your questions answered. And other than that, at this point now, you're done with the chapter. So you're going to move on to your Chapter 12 review, and then you'll be taking your test. So, all right, guys, thanks for sticking with me. I'm Mr. B, and I will see you in the next one. Bye.